So Unit 9, Lesson 2, Part 2. We are continuing on. We've already talked about checking the conditions. So as long as you meet the conditions, you can go ahead and find a confidence interval. The confidence intervals always follow the same standard format, where you take your statistic and you add subtract your margin of error, which is your critical value times your standard error of the statistic. So we just need to get what these values are so we could plug them in. We already said that our statistic will be x bar sub 1 minus x bar sub 2, our point estimate for the difference of population means. So if we consider that distribution, we had looked at before the rules for subtracting different distributions. And we had said that that means we're going to take the mean of the sampling distribution of sample means for the first group, and the means do get subtracted. That's what we're saying here. But what am I missing here? I feel like I'm supposed to be writing something else. Oh, that's what I meant to say. So that's just going to be the mean for the first distribution minus the mean of the second distribution. So I'm just going to write this as so we talked about how the sampling mean always centers at the population mean. That's why I jumped to that. It's a little more complicated for the standard deviations because we talked about how standard deviations don't subtract. So I'm starting with the variances. Variances don't subtract either, but we always can add our variances. So I'm going to add the variance of the sampling distribution of sample means for the first one to the variance of the sampling distribution of sample means for the second group. But we can simplify that as well because we had already talked about how the standard deviation of the sampling distribution of sample means is just the population standard deviation over the square root of the sample size. So I'm just saying that the standard deviation, so I will have to square that, population standard deviation for this group divided by the square root of the sample size of that group. And the same for the second group. So I'm just deriving this formula that we're going to end up just blindly using in a second. So I'm going to go ahead and square both parts of my fractions here. So I'll have sigma squared over n sub 1 plus, that should be sigma sub 1 squared, plus sigma squared of the second group over the sample size of my second group. Again, that's for the variance. So when we want the standard deviation of the difference of our sample means, the sampling distribution of the difference of our sample means, then it's going to be the square root of all that jazz. I forgot the one again. And there we go. It's an unpleasant formula, but it is what it is. Now, as we said before, we don't usually know the population standard deviations, so we can replace them with the sample standard deviation. So we'll be replacing that with S. I'm going to write S sub 1 and S sub 2. So the standard error, the thing that we will be multiplying our critical value by to make sure we have the width correct, is going to be, and remember the notation on the AP formula sheet looks like this. S sub x bar sub 1 minus x bar sub 2. Standard error, the sampling distribution of the difference of sample means, would be, I just wrote it out, but I'm going to write it again. Nope, not going to write that. I just said we don't know that. So I'm going to do the first sample's standard deviation squared divided by the sample size plus the second sample's standard deviation squared divided by its sample size. So this value estimates how much the difference in sample means will typically vary from the difference in the true means if it was repeated many, many, many times. So our typical description of what standard deviation is measuring, standard error is measuring. So as long as the normal / large sample condition is met, we can find the critical value T star for our given confidence level using either the table we talked about or the technology. And my kids are going to interrupt me, my apologies. What do you need? I will get you a drink in a second, yes. What's up, buddy? So I'm just filling in what we already know. We already knew our statistic. We've already talked about this critical value, and now we have the standard error of our statistic. Not new things. So this is going to be called in our plan step? I think it's the plan step. This is a 2-sample t interval for the difference between two means. Now, we do need to talk about the degree of freedom because it's changing when you have more than one sample, and it's kind of weird. You got two options. If you're using technology, if you're using the t-distribution, the degrees of freedom calculated by technology uses this formula discovered by some dude in the 1940s. My book doesn't. Usually it'll give like the derivation of these formulas. They don't even go through that, nor do they mention like to read more about, like they just say, here's what it is. And so it's a bare formula. It's understandable why nobody would ever want to do that by hand. But what this is going to result in is a margin of error that's approximately correct for the stated confidence level, which is what we want. However, this formula is rarely ever going to give you whole numbers. So if you're going to be using the table after you find a degree of freedom, remember when we talked about that weird round down rule? So that is an option. You'll see it on the calculator in a little bit when we do this. The other option is basically taking the more conservative option. If you're using the t-distribution, you can use the degree of freedom that would be equal to whatever smaller. Your first sample size minus 1, your second sample size minus 1. Now, if their sample size is the same, then you're just going to use whatever that sample size minus 1 is. But otherwise, use the smaller of the two. So this is the more conservative option. It will end up having a confidence interval with a margin of error that is as large or possibly larger than what's needed to have the capture rate that you're wanting. But it's sometimes an option just because gross. So both are accurate, both are fine to use. We'll talk about using both of them. So just to kind of sum this up, when your conditions are met, we have this formula for the 2-sample t interval for the difference between two population means. We already talked about t star. This is what's making C% of the area be between the positive and negative values, and the distribution using either that formula or the smaller of those two sample sizes. So I think I'm going to wait to the other video to do that because I have a feeling my kids are coming back out to interrupt me. So another short one, but at